We're going to look at factoring the sum and difference of two cubes. If you know the rule for factoring cubes, you've got this. There's really not any way to make this super complicated. It's a very straightforward rule. The best thing for you is to just put it to memory. And quite honestly, if you know one version, the other one is pretty easy to remember. When you factor them, they will always have the same basic form. You will have a binomial first, followed by a trinomial. So go ahead whenever you're setting it up, anticipating the size. You want a pretty small set, and then you're going to have a larger set. Now, this one I'm going to call the first term, and this one I'm going to call the second term. So every time we reference things, that's what we're talking about. First term, second term. The first thing you want to do is to do your cube roots. Okay. So what is the cube root of the first term? Well, if it's a cubed, then it's just plain old a. What's your cube root of your second term? Well, that would just be b. And please don't worry about signs until the end. Hold off on the signs. Let that be the icing on the cake. Don't even worry about that. Get your terms in first. These two are the very first two. That's what everything is built off of. Then you're going to come in here and you're going to put these other three terms. Now this is the way this works. This first one, it's going to be, let's see here, we're going to square the first term. Alright, so if you take the first term and I tell you what, I erred when I labeled this first term and second term. We really need to label them here after we've done the cube root. My bad. So, take your first term, square it. So whatever's here, a times a is a squared. Alright, now here in the middle, you want the product of the two. So whatever you have written over here, multiply them together. A times b is ab. And then the last one, you want to square the second term. So take your second one right here, multiply it times itself. B times b is b squared. It's always that form, every time. Now what you're going to do when you go back in, a lot of people call these SOP problems. I've heard them called SOAP, but more often I've heard them called SOP. That explains your signs. You have three signs here. This is for the S, this is for the O, and this is for the P, just so you know. The S stands for same, and that means same as your original problem. So go back to what was given. What is this sign? Whatever it is, copy it right there. The O stands for opposite. So whatever you just wrote, do the opposite of that. And then the P stands for always positive. So no matter what, this is always a plus sign. And just so you know, this trinomial here is always and forevermore prime. Some of you may notice this little pattern. It's really, really, really super close to squaring a binomial. Like if I've got a plus b squared, the rule for that is square the first, then it's twice the product, and then it's square the last. So we would have a squared plus 2ab plus b squared if we squared the binomial. And yes, you could take this and you factor it right back into that. But that little, since we didn't put this twice in there, it's just product. That means that up here, this trinomial is always going to be prime. You can never factor it. If you have to solve, you're going to have to use the quadratic formula on that portion. Okay? Now I kind of made a mess here. So let me get a brand new sheet of paper and, well, I'll see if I can squish it. Because I would love for you to compare the two rules. We'll just write it in a different color. How about that? So you should be able to do the same rule with a cubed minus b cubed. Do your terms first. Cube roots, a, b. Now go in and put your three terms. Take the first and square it. Do the product. Take the second and square it. Then do your signs. So same sign, opposite sign, always positive. So if you'll look at this one and this one, the actual terms are the same. The signs are what differ. That's it. So the only way to complicate this is to put some numbers in it. So we'll do an easy one and we'll do a more complicated one, and after that, you guys just need to practice. If you have one that just has, your variable has coefficient of 1, this one's like a easy level. And this one we're gonna say this is the hard level. Okay. Same thing. Prepare it. Cube root. Cube root. Now what is the cube root of 8? 2 times 2 times 2 is 8, so we need a 2. Alright, so now we got our terms. Go through and fill it in. Square the first. Product. So take these two suckers and multiply them together. Alright, take the last one, square it. 2 times 2 is 4. Then go in, do your signs. So it started with a negative, so according to SOP, we're doing the same, opposite, always positive. And that's as much as you can do for factoring. Okay? And if it asks you to solve, the first part would be easy. The second part would require the quadratic formula. All right, let's do one a little bit more intense, but the method is the same. All right, cube root of the first one. Well, we just did 8, so that should be fresh in your mind. You need to do 2x. Now, what's the cube root of 27? That would be 3y. Okay, come over here and let's build it out. We got our 3 terms. Take the first one and square it. Now, remember, you got to square the number and you have to square the letter. So if you square both, that's 2 times 2 is 4 and x squared. Then we come over here for product. You got to multiply all this together. So 2 times 3 is 6, and you got to have both the x and the y. Just if you've got different letters, just make sure you put them in ABC order. All right, then take the last term and square it. Square your number, square your letter. Then the finishing touch, use your SOP. Okay, he started as a minus, so you need to come in here and do same, opposite, always positive. And that pretty much covers everything there is that you need to know with factoring cubes. It's just a matter of practice. This is about the hardest problem you're going to have. You just have to remember to square when you're coming here for this term and this term. Make sure you're squaring your coefficient and your variable. I don't always use the appropriate terms, but I'm pretty sure y'all can follow me. Have fun practicing.